Okay. So in the last class, we discussed about what is a source code management tool, why we use it in our projects, and then different features that we get using source code management tool. And there is a official Git documentation here called ProGit. So this is how you can download it. Just go to Git official website. Just say download ProGit. Okay. Remember this, download ProGit book. Download ProGit book. You can go to this Git official website. Okay, click on this. You see here, red color PDF file. Click on that. So this is my ProGit book. Okay. So this is Git's official book. So I don't need to. 1 second. Okay, so this is the Git's official website. You don't need to read this complete book. Okay, you don't need to read complete book. Just take the first chapter, getting started. So here there is something called about version control, short history of Git, what is Git, command line, and things like that. So whatever you understand, whatever you can observe from it, try to take it. First chapter you need to read. Second chapter, Git basics. Third chapter, Git branching. 3 chapters are enough. 3 chapters enough. Okay. And again, book is always book, right? So you see a lot of theory and things like that here. Whatever I explain in the classroom, that you won't see mostly in this book, because I explain real time, right? So what we work on, and this is Git's official documentation. It will be always like definitions, books, and things like that, but everybody has to read these 3 chapters for sure. So Abdullah, I was just
Yeah, can you please repeat once, like which are the 3 chapters? And
for Git, this is the PDF ProGit book,
okay.
and then for 3 chapters, getting started, Git basics, and then branching. These 3 chapters you need to read. Okay.
So this book will be available in any, with you, like, or we can download anywhere.
So this just say download ProGit book.
Okay.
It is available. Go to this Git official website.
Okay.
Click on this red color PDF, and then it is downloaded. Okay, you can download it. Okay. So as I said, books always are definition oriented, right? But reading book will help you to develop the terminology, the proper authentic terminology. For example, even I have used this word. I am downloading the code from Git repository. We don't call it the download. We call it as clone, right? If you say download, people think that you don't have no proper experience. So by reading this book, you develop proper, authentic terminologies. So for that, you have to read the book. So go through these 3 chapters. If you cannot understand any word even or any sentence, you can call, you can ask me, okay? You can ask me. So you can say that, I don't understand this word, this terminology or, this topic, anything it is, you can ask me. Okay, I'll try to clear it in my own way. So that's about your Git learning material. So far I asked you to do 2 things. One, you have to continuously read that Linux basic Linux tutorial. That should be your daily learning activity. If you have finished that Linux basic tutorials, then go with the basic Linux commands. At least daily learn 3-4 commands, enough for you. Don't just learn the command, okay? Command with most frequently used options. Grep has some options, ls, -l, tr. So you have to learn commands with 3 options. So assignments, Linux basic tutorial, basic Linux commands, and then ProGit, 3 chapters. Keep doing it. If you need any help, you can let me know. Okay. So you know what is Git and then where Git comes in the picture in end-to-end DevOps automation workflow. Today, let me explain Git architecture. What's it? Git architecture. Again, if anybody has not yet taken the demo, I strongly suggest you to go through the demo first. Okay. So this is my Tomcat server. So developers write the code, correct? In their local laptops or desktops, we store application code in where? A repository, correct? This is your Git mission. Think that it's a mission. Here the Git is installed. And then once Git is installed in this mission, right, we create something called repository. So developers commit the code into this Git repository. As a DevOps engineer, this guy is DevOps engineer, okay? This is DevOps in his laptop. So what we do, we download the code. See, we should not call it the download, okay? We clone the code from the repository, or we say we clone the repository, but I'll be using basic words, okay? Just to make you understand things better for few classes. And then we build the code, we compile the code. If you go through the demo, you will understand what is build and then what is compilation and then why we compile the code. And then we create the var file, okay? And then we copy that particular var file into Tomcat server. We call that as a deployment. And then, as you know, people can use the URL and then they can access the application. There is a code here, okay? Tomcat server is there. Tomcat server executes the code and then it sends response back to the browser and then you see application here. That's how it works, correct? We are here now. So let's see how any user works with Git. For example, there is a user, okay? For example, developer, or it can be you, me, or anybody, okay? How any user downloads the code from the repository in his or her laptop, how users modify the code, how users submit the code back to Git, how people work. Let's see. Right? We are learning Git for 2 reasons. One, for ourselves, because as a DevOps engineer, we also write a lot of automation code, right? So we should know how to modify the existing code and then existing code in our laptop and then how to move it back to Git. And developers also take the code, modify the code, and submit the code back to Git. So if developers are facing any issue, they will come to you, right? So as a DevOps engineer, it is our responsibility to help them. So we have to be thorough with this topic. So this is my Git server. Git server means a mission, okay? A mission. And here there will be something called repository. Think repository as a folder. It's not a folder, it's a repository, okay? And so the repository, we store the code, right? So assume that you have login.java here, one file. Similarly, Think that you have 10,000 files stored in this particular repository. How many files you have? 10,000 files. Assume you have 10,000 files in repository. One file called login.java. Along with that, you have 10,000 files. Okay. So this is you. This is you, DevOps engineer, Harry, DevOps engineer or developer or anybody. Okay. Say Harry. Think it is you. Okay. So I joined in this project. And then my team members tell me, okay, this is where this is where we have our automation code. Can you go and then modify something? Can you go and then modify some code, some automation scripts or whatever, or developers, right? So they know where their code is. So when they join in the project, somebody will tell them where the code is present. So this guy has to work on something. So this is Harry's laptop, correct? So you don't have this project code, right? Assume that this project name is Flipkart. And what is the repository name? Flipkart. Usually project name will be our repository name. So Flipkart is the repository name. Okay. So Harry doesn't have the code in his laptop, right? What Harry has to do? Harry has to download the code, correct? So how Harry downloads the code? So if Harry wants to download the code, Harry has to run some commands. So in Harry's laptop, Harry is running this command. Clone the repository. First, Harry has to clone the repository using this command, git clone. So Harry has to execute this git command. Okay, what's that command? Git clone, and then there will be some URL. So every repository will be having some URL, https://github.com something. Okay. So when you join in the project, somebody will give you this URL. So how Harry can take the existing project code using git clone command. What git clone command do? The moment Harry executes git clone command, so there is you are giving the URL, right? So the git command will go to this URL and it will download the code. So we don't call it a download. Usually we call it as clone. I am cloning the repository, means I am downloading the code from the repository. Done. What happens when Harry executes git clone command? So the moment Harry executes first command, that is git clone command, what will happen? Whatever code you have in this repository, everything gets downloaded in local laptop. So the moment you run this git clone URL in your laptop, in Harry's laptop, it will first create a folder like this, matching the repository name. This is the repository name, right? So with the same name, to create a folder in your local machine. Inside this Flipkart, inside the Flipkart, okay, remember, it will create another folder called .git. You call this as local repository. What do you call this? Local repository. This is called as remote repository. Remote repository, local repository. So when you run this git clone command, what happens? Whatever code you have in the remote repository, right? Whatever code you have in the remote repository, everything comes in local repository. Think that this particular .git directory is the exact copy of this. Means what? You have login.java in the remote repository, login.java comes here. You have 10,000 files, say for example, you will get 10,000 files here. That means your .git is copy of remote repository. So we call it the local repository because it's in my laptop. And this is called remote repository. Think this remote repository is somewhere in the world, somewhere in the US, for example. Okay. Remote repository, local repository. You have 10,000 files in the remote repository. I get 10,000 files here. So that's the reason we call it as a clone. Clone is what? Copy, correct? So why we call it as a clone? Because this is local repository, the exact copy of the remote repository. So we call it a clone. I am cloning the repository, means I'm downloading the code from the repository. I'm cloning the repository. Okay. But okay, you are able to download the code. You are able to see, your remote repository code here, but you cannot modify the code directly here. You cannot modify the code directly in local repository, because as we discussed in the last class, what Git will do, Git will store your code, your file, correct? Maybe 100 lines of Java code, for example. It will also give a number to it, 1, 2, 3, 4. And then it will also store the information, right? History, who modified it, what time it is modified, why it is modified, correct? So, and then it has to store multiple copies, correct? 1, 2, 3. If this particular file is modified 100 times, it has to store 100 copies. 100 copies with 100 different names, and then some with some history. So it has to manage a lot of things. It has to manage all these things. So what Git does, Git stores your code in its own understandable format. Assume that it is login.java, login.txt. So when you push that login.txt to this repository, it not store it as a text file. It will store that file in its own understandable format, because it has to store username, what time it is modified, why it is modified, in some place, in some format, code in some format. And then if you modify, assume that this is 1 GB. If you have 100 copies, 100 into 1 GB, can it spend 100 into 1 GB? This is 1 GB, right? Assume that 100 times people modify the file. Does that mean that for each and every copy it has to give 1 GB, 1 GB? How much space? If you go real time, you see a file modified, say 10,000 times. 10,000 times. If this is 1 GB, it cannot spend 1 GB into 10,000 times, 10,000 copies, right? So it has to manage the space and a lot of things. So that is it. It won't spend 1 GB for each and every copy. It knows how to. It stores only the differences between the previous copy and things like that. But when you ask, it will give you everything. So basically, remember, it stores the code in its own understandable format. So when we run git clone command, it will create the folder first. It will get a .git inside Flipkart. And then whatever code you have in the remote repository, same thing comes in local repository, but you cannot modify this particular file because it is in its own understandable format. So we cannot directly modify the code in local repository. Then how do I modify the code? That's where it will give the same copy here in another area called source area. What do you call this? Source area. Think it as a folder. It's not actually the folder, but think it as a folder, okay? So same thing, whatever you have in the local repository, same thing comes here, 10,000 files. I'm just taking one file, okay? One file. Similarly, if you have 10,000 files, 10,000 files will come here. Done. And there will be another area here called staging area, stage area. So when you clone the repository, you get a folder. Inside the folder, you have .git. Inside .git, you have some code. And then along with .git, think that there is a source folder and then staging folder. So it will give you same code here also. So you have login.java here. You'll get login.java here, and then here. So why it is giving you the source area? Because you cannot modify this particular file directly, right? So that's the reason it is giving you same file in this source area, and then you can modify it. So that's what happens when you clone any repository. So now you are clear, right? You joined as a DevOps engineer in some project, you have to modify something. So you know how to clone it, right? Somebody will give you this repository URL, just say git clone and then URL, you get everything. Of course, I have not practically shown you all these things. Just try to take the concept today. Okay, so that's what happens when I clone the repository. Second thing, you modify the file. If you want to modify the existing file, you modify or create a new file. If you want to create, you can create a new file. Create new file in source area. Where do we modify the code or create a new file? We always work in the source area. Second step. So think that there is one existing file. Okay, I modify this login.java, I modified, or I can create a new file. So login.java file is modified. Assume I'm modifying the file. So where do we do our work? In source area. So once you modify the things in source area, then what we do? We have to move this particular file from source area to the staging area. So you have some change here, same change. You added 10 lines here, same 10 lines, you have to move to staging area using this using this command, sorry. So you clone the repository, modify or create new file in the source area, and then add the file, whatever you modified or created, to staging area. Stage area using this command, git add file name. Add file name. So you modified the file here, right? For example, login.java. So I have to copy this particular file from here to staging area. How do you copy that? This is the command we use. If it's a git add file name, this changes, right? If you modify 10 files, 10 lines here, same 10 lines will be copied to the staging. That means this file, both are same. Why we have to copy the file to the staging area, correct? There is a reason for that. We'll understand that later. For now, assume that you have to stage the file. Now, this particular file is copied to the staging area, right? Then we have to commit the file to the local repository now. Commit the file into local repository using a command called local repository using commit command. I'm not giving commit command. Sorry, I'm not giving full command. Okay, I'm just take the concept at a very level. We'll understand. We'll learn commands later. So what we have to do? Clone the code, modify the file in the source area. Second step, add the file to the staging area, and then commit the file into local repository. See, we call this as an add. Okay. Moving the file from source to stage is called as add. Usually we call it as add. I'm adding the file to staging area. We don't say I'm copying the file to the staging area. No, usually we don't. You can use, but right terminology what? I'm adding the file to the staging area. I'm committing the file into the local repository. So this operation is called as commit. Commit means you have something here, you are moving from the staging area to, you're copying something from the staging area to local repository. We call that as a commit. So we know, right? If you modify anything, for each and every modification, Git will create a separate copy, correct? It will create a separate copy, right? So this is the original one, which you cloned from the remote repository, correct? The first copy. This is the first copy. Now you modified this, correct? And then the moment you say commit, what will happen? It will create another copy for you. It will store the file with your modifications. You added 10 lines, for example, 10 lines are here. Okay. And then it will give a number to it. This is number 1, for example. This is number 2. So each time you modify the file, each time you commit the file, there will be a separate copy for it. There will be a separate copy for it. So this is a separate copy, right? It gives a number to it so that you can identify it. And at the same time, it will also store some information, history, who modified it, what time it is modified, why it is modified. So we call this as a commit. First commit, second commit. What do you call that? Commit. For each and every change, Git will create a separate commit. Commit has a commit ID. Commit has some history also. Who modified, what time it is modified, why modified, and things like that. And remember, these changes are still in your local machine only, correct? This is happening in your laptop, correct? Harris laptop. Now, if you want to publish your changes to other users, what you have to do? You have to push your changes to the remote repository. So other people, all your team members, all the users who are working in the project, they all connect to the remote repository and then take the code. So it is like this. You have something here, right? People take the remote repository into their local laptops. They do their work in their local laptop. Once the work is done, they upload or they push this. We don't call it an upload, okay? We don't call it upload. We say push. They push their code to remote repository. So once I commit my changes to the local repository, I have to push my changes to the remote repository using a command called git push command. What's that command? Git push. Just say git push. What it will do? You have one extra change right here. So whatever code you have modified, that will be pushed to the remote repository. So in remote repository also, this is the initial one, right? First copy. It will create a new copy, login.java. Second copy. This is what you committed, right? Second commit. And then here also it will store who modified it, what time it is modified, why it is modified, things like that. So this is your change now. If you have added 10 lines here, you see 10 lines in this copy. This is the latest login.java or whatever file it is. And that means you published your changes to the outside world. If you push your changes to the remote repository, anybody in the project can take it by connecting to remote repository. For example, Sally. Sally is also working on the same project. Now, Sally comes to you, says, Harry, I heard that you were working on something, right? Once your work is done, I have to develop something on top of yours. Is your work done? Harry says, I just finished my code, right? And then I pushed it to the remote repository. You can take the code from the remote repository. So what Sally will do? Sally will take the code from the remote repository. What Sally will do now? Sally also will clone it in her machine. She will also get what? Local repository, source stays, these three. Okay. Sally will get the latest copy. Okay. This one, latest. It will give the latest. L. And then she can also modify. She adds the file to the staging area. She commits. It will get a separate copy. Again, she pushes. This is Sally's code now. Okay. Third copy. And this has become the latest now. So that's how people work with remote repository. Understand this? This is called as Git architecture. What are the different components we have in Git architecture? There is something called remote repository. Remote repository is the place where all users connect to for collaborating with each other. That means for exchanging the code with each other. There is something called local repository. Source area, staging. Source stays, local repository, remote repository. We take the code from the remote repository, we modify the code in the source area, add it to the stage, commit it, push it to the remote repository. So remote, local repository, remote repository, source stays. Now you understand how people work with any file modifications. Any questions?
So I have one question, sir. So after modifying, like how will I know that whatever I modified is right or wrong?
Means, say for example, you write some Java code, right?
Uh,
Or as a DevOps engineer, you write some automation code, right?
yeah.
So how do you know whether it's something? You have to run and check it.
Okay.
See, okay, I'm a developer, for example. Okay, I write login.java here, correct?
Yeah.
So once I create a new file, once I write login.java, for example, I run it, I compile it, I compile this particular file, I execute this, and once I feel that okay, things are working fine, then only I will add it to the stage, I'll commit it, I'll push it. So code goes to the everybody. So before we commit the file to the local repository and push it, we can
Mhm.
run that file. So once it is tested, then only we will push it to the remote repository. Otherwise, we will be working in our laptop only.
Got it.
That's about Git architecture. If you read this ProGit book, they explain the same thing in their own way. This is my own diagram. This is my own diagram. You will not find this in Google. probably something similar to this you may find, but this is a simplified version of it. Okay, so read ProGit and try to understand the same thing there. Okay, I'll practically show this to you. Okay, I'll practically show this Git architecture. Right, we are going to clone a repository. We are going to modify something. We are going to push it to the remote repository. We will be doing all these things. I'll show all those commands to you.
Okay. Nagesha, like
Yeah,
many people are like making the changes and pushing, no? So every time they are creating the like duplicate, right?
it's not a
Suppose
duplicate. So every time, see, you are committing something,
uh,
you're pushing something means each and every copy has something new, correct here.
yeah,
You,
so like my question, like every time they are creating the new copies, no? Like
Mhm.
so multiple people doing, multiple teams are doing. So it will be like not creating the space or like space. It will occupy space and it will create a lot of duplicates, no?
Yeah, that's the intention here, right? So we call that as versioning. That's a feature. Versioning, or we call it revisioning, means what? We want to maintain multiple copies for each and every modification. We want to maintain a separate copy so that we can go back to the previous place, previously working code. And then if you want to know what happened here, if you want to know what happened here, say 1 month back you fixed a bug, for example, right? So you want to know, right, what code has been modified to fix that bug, how many files are added, are modified to fix that particular bug. So you have the complete history. So for that history, right, we want multiple versions. That's in fact a feature. That's a feature of source code management. We call it as versioning or revisioning. That means I'm maintaining multiple revisions, multiple versions. So that's a feature that is required. But you asked a valid question. What about space, storage? That's a concern, correct?
Mhm.
So as I said before, if this particular file has 1 GB, right? And if this particular has been modified 10,000 times, does that mean that it has to spend, 10,000 into 1 GB, 10,000 GBs? That's too expensive, right? So it
Yes.
won't do that. It has its own way of managing the files. Okay, you asked this question too early. Let me explain it. See this. This is how it stores the code, okay? So for example, this is your laptop, okay? You create a folder and then you push it to the Git. There is a folder. Okay, commit one. This is your laptop, okay? I think you, assume that you worked in your laptop and then you pushed it to the remote repository. Folder, there is a folder, okay? It's a new folder, right? So it will get a number for it. It will give a version number for it. Again, you add a file. Assume that this is 1 GB, okay? And then you push it. For each and every change, it will get a separate copy, correct? 2. So whatever you have the previous plus what you modify in that particular commit. So first time you created the folder. Second day, for example, you added this particular file. Okay, size is 1 GB. And then you push it. There is separate copy for it, right? Again, say for example, you create another file. This also has 1 GB. Okay. Again, you push it to the remote repository. It will get third copy, correct? Third copy will be having 1 plus 2 plus 3. So this is 1 second plus this one. So this is the file which is coming newly here. Now you see this. This is 1 GB, right? So when you push this in second, commit, it will spend 1 GB for sure because first time the file is coming, right? It has to store it, correct? It's a original file. So it will spare 1 GB. It will spend 1 GB here. But here it will not spend 1 GB again because this is a duplicate one, right? So in second revision, there is a file. In third revision also you have the same file, correct? So here it will not give you 1 GB. But in third commit, this is the new file, right? So first time it is coming, so it will give 1 GB for this. Assume that you create another file, okay, 1 GB. So for each and every change, it will create a separate copy, correct? So for now, it will create fourth copy, right? So this is the previous data. And then this is the new file which is coming. So it will spend 1 GB only for this because first time it's coming. And this one is a duplicate one. This one is duplicate one. So it will not spend 1 GB again and again. So the original 1 GB here, this arrived originally here, it will give the 1 GB. This arrived originally 1 GB. And here duplicate. So see the how commit structure looks like. So first commit, second commit, third commit, fourth commit. Which one is the latest now? Fourth one, right? Now you tell me if anybody takes the code from the remote repository now, what code it will give to them? Latest one, right? What is in the latest? Folder, file, file, file. So folder, file, file, file. So it will give the latest. Total 3 files and then 1 folder it will give to Sally. So it will give the latest. So Sally can work on this 3 files. So for Sally or for user, it gives a feel that yes, I'm taking latest, and then it will give you everything. All 3. But is it storing these particular files originally here again and again? No, it is not storing. Okay. For example, see, this is the thing, right? Feature of versioning. Assume that there is some issue with this particular file which has come here. I want to go back and then take the previous one. You say 3. If you take 3, what you will get? 2 files you will get. Assume that this also has some issue. What do? I want to go the previous one and take it. So if you take it, you will get till whatever thing was there till that point, you will get only that. So you have that flexibility, right? But is it for you? It is maintaining everything in each and every commit, but internally it is not allocating 1 GB again for this, 1 GB again and again for this. No, it knows how to manage the space. They say internally it uses a technology called snapshot. What is it? Snapshot technology. Using snapshot technology, right? It will be able to maintain the file. It will be able to maintain the duplicates in each and every commit, but it will not spend same space. Think like this, maybe it is storing some memory reference. This is the original file, right? This file will be stored somewhere in your memory, correct? It stores, think that it stores only that memory address. What's that? Memory address in KBs. So again, it is storing that original file's memory address here. If somebody takes the code, it gives the folder, and then it has to give this particular file, right? Is this original here? Is it present originally? No. So but there is a memory address, 1, 2, 3, 4, for example. So it will go to that memory and that will give that file. So it doesn't need to maintain 1 GB duplicate copy in each and every version. No. So Git, that's a job of Git, correct? That's why we are using Git. So that's a job of Git. That's a intelligence Git has. So it says, I'm there, I'm a tool for you, I'm a software, I have this intelligence, right? I'll give you multiple copies. You can modify the file any number of times without you worrying about the storage. And that is me, and that's me, and then I'm a technology, correct? So they say internally they use something called snapshot technology. So think that it stores only the memory location, memory address. But for when somebody asks, it will come here, folder. Do you have the original file here? No, there's a memory address, right? It will go to that memory and then it will pick it up. Is this for file original? No, there's a memory address. It will go to that memory and then it will pick it up. Is this original? It is physically present there, so it will give you. So for you, it is giving all 3 files. But is it storing 3 files in each and every copy? Is it all 3 files are physical present? No. That's a technology. They call it as snapshot technology. So you don't have to worry about storage space. In fact, if you go real time, you see a file having 10,000, 20,000, 30,000 revisions. 10,000 times a file has been modified. That's very common, and we don't need to worry about that. Clear with that?
Yeah.
Everybody, you understand that? Any questions you have so far? Okay. Any questions? Anything you want to understand elaboratively? If you have any confusions, you can ask me. Right? I have little confusion here. What do you mean by this? Anything, any such thing you can ask me.
Yes, Nagesh, I have the small doubt. So when we clone a file from Git server, so will it be saved in both source and local repository, or it will be like in which it will be stored initially?
It will be there in both. Think that you have a copy here, you have a copy here, you have a copy here. In source area, staging area, and then local repository. But again, for you, it gives a feel that it is present in source, stays, local repository, but it is again managing something here, storage. So, but we have to think, for sure, you will see the file here, okay? It will be there, it will be here also. This is kind of an imaginary part. So, it is like, imaginary folder it is. So, think that yes, the files are stored in source, stage, and local repository. Yes.
Okay, thanks.
I'll show that to you. So this, you can see the file present, you know, physically here also, but this is kind of an imaginary folder. So, this won't be there. I'll show this to you later. Then, okay.
Yeah, okay, thanks, Nagesh.
Mhm. So that's about the Git architecture. Let's see how we can install Git. You all know how to install something in Ubuntu, right? Can somebody tell me how you install something in Ubuntu? So now you know the basics, and then architecture at a very high level. I know we have not done anything hands-on so far. So that's the reason we are installing Git. Okay, once the Git is installed, then we will practically execute all this. How do you install Git? How to install something in Ubuntu? What is that command we use? How do you install something? What is that Linux command? How do you install?
apt get install git.
So before we run apt get install, we run apt get
Git
update, and then apt get install Git. This is the package, okay? Package means the Git. If you want to install Git, this is the installer name. Think that way. We call it a package actually, and we have to execute apt command with what? Sudo always. Explain this sudo command in basic Linux command session. Okay, so if you run apt get install Git, what will happen? This apt get command you're executing in your Ubuntu, right? This is your Ubuntu machine, right? So this apt get will go to this download center. Here you have Git. It will download the Git and then it will install in your laptop. Okay. And if you want to get the latest version of Git before apt get install, you have to execute apt get update. So before we run apt get install, it is good to run always. It is always good to run apt get update. So I'm going to install Git now. If you want to install Git, it is apt get install Git. Okay. If you want to uninstall Git, apt get remove Git. apt get install something, apt get remove something. So Git is already installed in my machine. It is already present. So I'll first remove it. Okay. Sudo apt get remove. I'm uninstalling it. Okay. Are you sure you want to continue uninstalling? Yes. I just typed Y. There is no Git command. It says Git command not found. So that's what you see in your Ubuntu. Okay. I'm going to install Git now. How to install Git? Sudo apt get update so that I can get the latest Git version. Then say apt get install Git. apt-get install git, apt-get install maven, apt-get install java, apt-get install blah blah blah, things like that. It's not always for Java it is Java, for Maven it is Maven, for Jenkins it is Jenkins. The name can be different, okay? That you will have to find in Google. What is the package name for JDK11? What is the package name for this? If you Google, you will get that package name, then you have to give that one. Installing Git. So once Git is installed, you can check the version. Git version. So what is that version of Git I have in my machine? 2.25. This is the version of Git I have. And if you want to know where git command is installed, use a command called which is the Linux command, okay? Which git. See, git has been downloaded and then it is installed, right? It's downloaded and then installed in my machine. Where is that git? Where is it installed? It is installed under a folder called user. Under user, there is another folder called bin. Under bin folder, git command exists. If you want to know where a particular command is available, use which command. Which git, which maven. Maven is not installed. Which Java, right? Java is installed here. For Maven, it is actually MVN, okay? See, Maven is here, Java is here, Git is here. So which will tell you the location of a particular command. So once the installation is done, execute this Git version. So you will see something like this, right? So this command is working means, okay, Git is installed successfully. And if you want to remove Git, apt-get remove Git, apt-get update, apt-get install, okay? Which Git will tell you the location, Git version. Using Git version, you can print the version of Git that you have. If you want to remove it, apt-get remove it. That's how you install Git. Clear about the Git installation? Any questions about the installation? So you all have a Linux machine locally, correct? So today what you have to do after this class, before you attend next class, make sure that you all have Git installed in your machine successfully. In case of any questions, you let me know. In next class, I will share these notes. So this is how we work, okay? So every day, whatever I explain theory, okay? Then I explain practicals. I do practicals. Whatever practicals I do, everything is captured in these notes. So after the class, you have to keep these notes in front of you and then you practice. Okay. There are some project work also. Those steps are also here. That's how we work after the class. For now, you can take a picture of this if you don't remember apt-get update install, because I'll share the notes in next class. So that's all from my side for today. Any questions? Go ahead. Any questions?
No, all is fine.
Okay. Okay, so that's all from my side. And people who were not paid fees, okay, you can pay the fee before next class. Somebody, I mean, few people of you would have paid some part payment, right? So make sure that you pay remaining fees. If you have any questions, you can talk to Aisha or send a message to me on that.
And Aisha, can you add me in the WhatsApp group?
I'll add you, Abdullah, right away. I'll ask Aisha to do it. I don't remember the group name. I'll ask her to do it. Have you updated the cheat sheet for Linux commands, Rajnish? Rajnish, it's not present in Linux. Okay, I'll update it. Okay, that's all from my side. Good night, everybody.